So thank you, Luigi, for introduction. So if you've seen the picture of me, it was 10 years ago. So you can tell how quickly people age. I hope you say, no, you haven't changed since. But nevertheless, I know best how much I changed. So my topic was on the mobility itself, and there is basically nothing to disclose financial. But the mobility, we as a geriatrician, we just encounter mobility early in our training, being that the old 1970s and 80s 5 I's of geriatrics, like instability and immobility. But mobility problems are one of the geriatric syndromes, falls, balance problems. Is part of core activities in ADLs, IADLs, mobility disability as marker of dependence and service needs, then mobility as part of comprehensive geriatric assessment, and we go to it a little bit later on. But mobility also as a walking speed, as a new vital parameter, and then mobility limitation as a clinical sign of physical frailty and sarcopenia, and mobility locomotion as a domain of WHO intrinsic capacity concept. Probably less complicated are these 5 M's of geriatrics, Canadian Professor Molnar. So you see, all start from M, and mobility is one of them. If we think about mobility, and I thought, because it's a presentation I've never gave before, so I just looked in some literature more closely, and we have a very narrow definition. Mobility like a simple moving around, walking and climbing stairs. Then we have the WHO ICF model, moving by changing body positions, transferring, manipulating objects, walking, but also running or climbing, and using various forms of transportation. And then we have even more broader definition, which basically includes free movement in our environment, outside our home, and very much depends on the environment we live in, and also to go and live our social life without any restrictions. And this is the last definition, which is called life space mobility, that you can go to a theater to meet friends, that you do things you enjoy and like. And then we go to a more holistic model, which I may skip anyway, but what I would stress, the environmental functions, the physical and also psychological and social influences on our mobility. If we go to the epidemiology, what we know, about 1/3 of people 65 plus may report mobility limitation. And we have seen in Luigi's slides as well. But unfortunately, it goes worse when you go close to 80s or 85. And there are some known mobility limitation predictors, like chronic conditions like arthritis, Nicola will talk about, but also stroke, diabetes, obesity, chronic end-stage diseases, chronic heart failure, and some others, and pain and conditions, and so on and so forth. This is a Czech slide, actually, because I'm from the Czech Republic. So in our population 65, we have the average 37% of people, the self-reported mobility limitation in walking 500 meters. So it's quite a lot, for almost 40%. In US, it was quite similar, but it was little less, like 5% less. So we have to be careful, but even in the general population, about 30% of people suffer from that. If we go from mobility to locomotor capacity or locomotion, so it is defined more narrowly as the musculoskeletal system that encompasses endurance, balance, muscle strength, muscle function. So it really deals with the musculoskeletal system. So its locomotor capacity is a domain of WHO intrinsic capacity and relates to the individual body functions, whereas mobility reflects the interaction between the environment. And one of the conditions typically now, we discuss typically now, is osteosarcopenia, or also the sarcopenic obesities. So it's very closely related to the third presentation, and you know how difficult it affects the older people. But what we started talking about at the first introduction is that we really should measure mobility somehow in a quite reliable way, because it has a really good predictive power of different adverse outcomes, be that falls, be that hospitalizations, be that even mortality. So it's a very powerful predictor. So what we should do, we should know how to measure it. So what we need a standardized protocol, standard operating procedures for measurements. And the parameters we can measure is not only the gait speed, but it's also the balance, tandem, single stance, or more sophisticated. Then is a chair stand, which is also quite strong predictor and reflects also the sarcopenia in lower extremities. But there are more 6 minutes walk, which is very much used by pulmonologists after COVID, just having the functional idea of how the patient functioning. But also the timed 400 meter. How long does it take you to walk 400 meters? And we have also some cutoff points. As Luigi said, for gait speed, we have a cutoff of 0.8, or for general community living people, it is just below 1, because it is the cutoff which says it might be sarcopenia already and it is dangerous. But for example, to cross the road or street on the traffic lights, do you know how quickly you have to walk? How is it calculated? It's 1.27 or 1.3. So you have to be able to walk a little bit quicker than Luigi showed us to cross the street. So this is another important cutoff probably, which is very important for the universal design of cities. So, and by the way, for example, Asian people, walking speed is much quicker than the European ones, you know, they just walk more quickly. So it is important to measure it, but we need a really reliable measurement. And I just found one article which says you have to be really careful how to measure, because the standard error which we achieve with normal stopwatch when we measure gait speed, so we usually measure 4 meters, or some recommend even 3 meters, but mainly 4 meters walking speed. So its standard error is 0.1. And so if it is 0.8, 0.7 or 0.9, we see that the cutoff might be a little in danger. And also the minimal detectable change, if we design intervention studies, so we have even, you know, the more harder sort of limit to achieve to show that the intervention is working. So, and you see for the gait speed, so we need really probably more reliable measurements. And here we come with ICT, different measurements, variable sensors. We can use, you know, for walking speed, a specific platform you walk on. You don't need anymore your watch. But we come also to artificial intelligence, which all of a sudden could measure it much better than people senses and people abilities. So this is probably the future where we want to get. And also, when I talk about the life space mobility, which I already described, so this is younger age, greater lower extremities power, and so on and so forth. But we look for the factors we can modify to improve our quality of life, because the life space mobility is reflected by our health-related quality of life. And it is, I'm sorry, it's not very readable, but you see the gait speed is quite a good, has high, I mean, steeper slope. Then, for example, there is a nutrition, I can't read it myself, so you maybe can read it. But what is the most important is the ability to drive. If you are unable to drive or cannot drive, is the most important predictor. That was the US, and so this is important to be able to drive much more than in Europe. But nevertheless, so we have to look not only for the physiological function, but we as a doctor will, but as epidemiologists, public health people in public health, we should look for that. And so these are the recommendations, and currently we're just talking again about frailty and sarcopenia, so it's a more narrow part of our older population. However, what we have a physical activity, we have a nutritional approaches now, we don't have drugs, we're looking for them, but still not fully successful. And if we look for the mortality, this is the same study Luigi already showed and talked about. So this is the gait speed in women and men from age of 60 to age of 95. And you see, this is how quickly they are able to walk. So the walking speed and the mortality goes down, but the difference is still here up to a very old age. So it is even important if the 87 years old female is walking quicker or slower to predict her mortality. Actually these points, this is a population which was involved in a study I'm going to talk very quickly about in a couple of slides. And this is a sprint study, which was a study which compared multi-component intervention, which was either the exercise, structured exercise and supervised exercise, plus some nutritional advice, assessment and recommendations, plus compared to the HALE, so is healthy aging, educational activities. So we have the physical activity, nutritional assessment. This is our Czech sample. There are also samples from, so the people exercised in different parts, outside, inside, and use of healthy technology and just the accelerometers to look for their gait speed and mobility as well. And then these participants were, quite old, almost 80 years old. They had a low muscle mass, and they were really very frail. And what happened after 3 years intervention, we have 2 to 3 years intervention, we found the mobility disability decreased by 23%. So in the intervened sample, which is quite good achievement, taking into account how old these people were and how they disabled, frail and disabled they were. And then it reduced the disability, mobility disability also in people with cardiovascular diseases, with diabetes, and some other conditions. And looking at their gait speed, it was quite interesting because the SPPB test, short physical performance battery, from 3 to 7, these are people who have balance problems, slow gait speed, and also chair stand quite slow or even not at all performable. So you see the difference which persisted for the whole time, and the intervention worked much better to those who were more disabled than to those who were less disabled. What happened also, nutritional improved. We achieved the nutritional target of over 1 gram of proteins per kilogram of body weight, and these are the summarized results. So a lower risk of developing mobility disability, improved physical functioning, and actually we found even the decrease of muscle loss in women. And the last project I'm going to talk about, 3 slides more, I'm sorry, so this is a SONATS project on nutrition in critical period of your life, which is the transition to retirement age. I think we already tried something what will happen once we retire during the pandemic. We stayed at home, had a good snacking and everything, little movement, and there were some people who moved better than and more. But so what will happen? Okay, nothing. Okay, now a magician will come, okay? No, so first we try to identify the target phenotype. What we did, we found, and also look for people with sarcopenic obesity. We don't want them to lose muscles and be obese even more. So this was a Rotterdam study. Then we identified, try to identify the effective intervention in this a period of age, which we found only 3 studies, randomized control studies, and this is how we're developing the SONATS application, which where you can choose yourself your personal goals. So it's personalized, it's evidence-based, and we are just trying. We will start the pilot feasibility trial to look how it really works. And that's all. So hopefully I will be able to tell you some results next year. So thank you for your attention, and sorry for a little bit time. Thank you.